Okay, so if I take this here, okay, really quickly just to recap where we're at. Alright, so good man. Now we decided that we sort of ran out of time at the end, right? We decided that B is the velocity of the bullet and C is the clay pigeon, alright? And at the very beginning, at the beginning of the question, we decided that this person here, what is it? The clay north 70 degrees west. Okay? So that's C and that's B. Alright? It's 120 degrees here. It's it's 120 meters. And this will also be the direction of phi BC. Phi BC is not 120, but it has to travel 120 meters to reach C, given that C is the one that we're considering to be stationary. So we chose C to be stationary. Somebody else could come along and choose B to be stationary. That's your prerogative. Okay? We said phi BC is phi B minus phi C, and then we rearranged it to get the equation below. Now what I keep telling you guys is that we need 4 pieces of information to make this work. The velocity of the bullet is 250. The velocity of the clay pigeon is 40. It's going in the direction east 40 degrees north. And the direction of B to C, as on our diagram, is west 20 degrees north. Otherwise known as north 70 degrees west. Okay, same deal. So, here's what we're going to do now. I'm just going to remake, I'll just remake the triangle and we'll take it from there. Alright. So, okay. So here's what we're going to do. What I told you yesterday is you choose a common start point. So this means that phi B, which is your bullet, you don't know what direction that's going in. All you know is it's going 250. So I'm not even going to give it a direction. I'm just going to point it downwards just for argument's sake. I'm going to fix it later on. Next we go to one of these. I have all the information on phi C. So phi C is east 30 degrees north. So phi C is east 40 degrees north, 40, which is relatively short. The two of these, because they're adding together, they join end to end. Okay? So now we'll go for the next one, which is west 20 degrees north. So, and I'll allocate a different color to it. West 20 degrees north. I think I'll have it around here. I think I'll have it longer. And then all of a sudden it becomes clear what I need to do with phi B. Phi B needs to join that triangle up. We all good? So, this is phi B, this is phi C, and this is phi BC. Okay? Now, phi BC we don't know. Phi C we know is 40. Phi B we know is 250. And now we're going to put in some angles, okay? So, what can we say about this angle here? I'll highlight it. What can you say about this angle here? Anybody? No, did not want to do that. Alright. Part of it is 20 degrees, isn't it? Would you agree that part's 20? And what about the red line? What angle does the red line go up at? Red line's phi C. What angle does it go up at? 40. Using alternate angles, what can you say about this? Also 40. Add them together to get 60. Okay? Now, Gonna show you two deviations here. Okay, 60. Now, the problem is you know nothing about phi BC, do you? Currently, we know nothing about phi BC. Some people use the T method. How do you convert velocity into distance? Multiplied by the time it's spent travelling. So some people said, I'll put a T here, I'll put a T here, and that means I can now use the 120. Why am I allowed to use the 120? Because it's a distance, not a speed, right? That's one option. Then you can go for a sine rule here. You can say sine 60 over 250t ends up to be, we could do a finding out one of the, if we reread the question, what does it want from me? It wants the course. So what does it actually want? It wants the direction of the bullet. So which angle would be the most direct route to that answer? Call it angle A. If I find out what angle A is, I already know that this angle here is 40. So it's in a straight angle. So if I find out angle A and I use, I can find out angle A. Now, problem with this method is that if I go directly after angle A, you'll see an issue. Alright? So what happens if I go directly after angle A like so? What's the issue? How many variables do you have? T and A. Two variables, one equation, correct? But if I didn't use sine A over 120, but instead I used the other angle, which we call angle B. What about angle B? What happens if we use angle B instead? What is it? Sine B over 40t. What happens to the t's? The t's will cancel and we'll get 40 sine 60 over 250 equals sine B, and I should be able to calculate that. Lads, please make sure you're in degrees for this one, and when you're doing differential equations you're in radians. We'll get to that later. So we shift sine inverse our answer and we get 7.96 degrees. Now, is the other answer acceptable? Is there's generally two answers. Is 172.04 acceptable answer for this question? Yay or nay? You should be able to tell me right away if it is or it isn't. No. Why? It's too large. There's already a 60-degree angle in there, so it isn't going to work. So that's gone. Okay. And now what you can say next is that you can next say that angle A equals 180, take away 7.96, take away 60. Angle A is, here, let's do it here, 180 minus 7.96, take away 60. Angle A is 112.04. And now, if we zone in on this part here, which I'll make a bit larger for you, onto the new page. That's 40 degrees. That's 112.04. This means x is 180, take away 112.04, take away 40, which is plus 40 minus 180. 27.96. So that's 27.96. Now how do I describe that? West 27.96 degrees north. Is that okay with you guys? Alright. Now if you go back a step, we didn't need to use the t's either. If you never converted this into a distance diagram, the t's weren't just there anyway, so you would have got the same answer. whether you left it as a velocity or you did the t method. Still the same answer no matter what. Okay? Now, next thing we're going to have to do is part 2 would like the flight time. So what's the time taken? So if we go back at this again, where is it? Oop. No, that ain't it. Oh, that is the wrong chapter. Sorry about this. Right, sorry, don't know what happened there. Right. So let's go back at this again. So we know what B is now, don't we? So we can find the time directly like this. So we can say sine B over 40. But we know what B is, don't we? B is 7.96. Okay. Equals, what's it? Sine 60. Sorry, I'm going to go for the 120. Sorry, I'm going to use the 120 because it's the only one that hasn't got t in it, which means they won't cancel, which means I need to use sine A. We know A is 112.04 over 120, and this should get us, this should directly get us t. Move the t from the bottom left to the top right, and then do 120 sine 7.96 divided by sine 112.04. So that's 7.96. We'll put in the calculator now. Divided by sine 112.04. Sorry, am I in degrees? Did I drop the 40, was it? I dropped the 40 by mistake. Yep. T equals 0.448 or 0.45. How many people got that one out? Just you and Alex, sorry. Fair play. Tough. Alright, let's go to the next one. The next one had some, yes? Yeah. Now, next question. A swimmer wishes to cross a river. Okay? Swimmer wants to cross the river and as quickly as possible. What does that mean when you do it as quickly as possible? Yes, Connor?
It's like,
oh, sorry, I'm wrong there. It's 48 and 64, isn't it? So you get carried downstream 48 and you cross, it's 64 wide. Some of you did Pythagoras' theorem straight away. Fair play to you, you got 80. You travel 80 in total, so this red dot's the swimmer. And you go, do you know what? I'm going to aim up this way. But the issue is that the river has a current traveling directly to the right. So even though you aim directly up, you're actually getting pushed across. So you actually end up going this direction here, and you're all the way downstream. But what we know is this: you're aiming all your effort, which is P. It's going P up and Q across. Does that make sense? Alright? And it says it takes 96 seconds. So, what's 64 divided by 96? Anybody? Distance divided by time. So, you travelled 64 metres upwards, which is all down to P. So, 64 divided by 96 is 2/3. Quite simply put, P is 2/3. You probably kick yourself for this now, had you not got that, alright? And Q is 48 downstream, which is 48 divided by 96. And what's 48 divided by 96? A half. Oh, sorry, so Q is a half. meters per second. Try and remember your units. Okay. Everybody on board so far? So look, that was a gimme. That's 10 marks on the board, not even remotely stretched. All right. Now we're going to go in the reverse situation. So the reverse situation looks a bit like so. The red dot is now the start, and the blue dot is the finish, and we have to figure out how we're going to get home. Okay. First of all, can we get home? Is it possible to get home? Yay or nay? Why is it possible to get home? Swimmer is faster than the current. If the swimmer is faster than the current, you can move any direction, anywhere. Okay? So it is possible for us to go all the way back down here. Happy days. Okay? Yeah, I did construct a triangle. Alright. Now, let's think about this logically here, right? So we'll call the swimmer S, and we'll call the river R. Do I use phi S R or phi R S? Is the velocity of the swimmer in the river, or is the velocity of the river in the swimmer? I'll say that one more time. Is it the velocity of the swimmer in the river, or is the velocity of the river in the swimmer? Which one makes sense? VSR is the one that makes sense, alright? Now, VSR is how fast you travel in still water. That's the deal with that. VSR is how fast you travel in still water. Now, VSR equals VS minus VR. Arrange it though that VS is on its own. Alright? Now, if you're really confused by this, at this point I'd ask you to make up a really basic example. An example like this. Swimmer can travel 5 meters per second. River travels 3. Some dude looking at the swimmer on the bank. How fast does the guy on the bank see the swimmer go? 8. Exactly. Velocity, the actual velocity of the swimmer is 5 plus 3, which is 8. Does your equation make sense? It does. Okay? If the river was going in the opposite direction, where it was minus 3, how fast would the observer on the bank see the swimmer go now? 2. That's because that would be a minus 3 instead of a. So that equation makes complete sense. Right? So now we're going to use that equation, and we're trying to assemble, there's 6 pieces of information. If we assemble 4 pieces of information, we're in business. Means we can do it, no questions asked. Alright? So let's make our little grid. Okay? And we're looking for magnitude and direction. Okay? Mag and direction. Right, first things first. Do we know the velocity of the river? What way is it going? 0.5 directly east. Do we know the velocity of the swimmer in still water? What is it? 2/3. Okay? So this green line represents the swimmer. If he aims straight down, he'll get swept downstream. If he aims too far downwards, he'll get swept downstream. So the swimmer is sort of aiming somewhere in this direction here. And what happens is the current is pushing him. The current will push him on line. So he's trying to follow that green line, but the current will push that line to the right, and he'll end up going the direction he wants. So that green line represents the angle he'll probably attempt to do. Does everybody get that? That's pushing them. Okay? Now, we don't know this angle. This angle is obsolete. We simply don't know it. Okay? Now, what we do know, however, is we know the direction he needs to go downstream. We just haven't done it yet. How about tan inverse 64 over 48? $53.13. Now what direction is that according to east, north, south? What do you reckon? East. Yeah, east 5313 south. How many pieces of information do I have now? Okay, this should be plain sailing now, okay? Oh, sorry, west. Ugh, sorry. I was thinking east as well for some reason. It's definitely west. West is left, east is right. Thank you for that, Michael. Now, next thing. Here's the difficult part for most of you, is it? Okay. Alright. Owen, pick me a good... So there's three choices, okay? Pick me one of the vectors to start off your triangle with. VR is a great choice. Why is it a great choice?
Because you've got the magnitude and the direction.
So what do I do? Just draw a short line to the right, don't I?
Yeah.
Great. Right. Now, yeah, what's the only other one you know the direction of?
VS.
Now, does VS join end to end, or does it have the same starting point?
Same starting point.
So what do I draw then?
West.
53.13 south, yeah. And I think it'll be slightly, it could be shorter, it could be longer, I actually don't know yet. I'd imagine because you're fighting the current, it's shorter. If you're with the current, it would be longer. Do you get that? Alright, sorry, let me once again refer back to the really simple example of the swimmer going 5 and the current going 3. If you're swimming with the current, your VS will be bigger, as in a longer line. If you're going against the current, your VS will be more than likely smaller. Maybe it's not going to be the biggest line in the triangle. It's either the smallest or the second smallest, okay? So, and even knowing that information doesn't really matter. The maths takes care of it anyway, okay? So what I'm going to do is I'm going to accentuate the 0.5. This 0.5 is going to be a lot bigger looking, and I'm going to make this slightly smaller because I know you're fighting the current. Okay, now next question is, which is the only one I haven't used yet? What is the only vector I haven't touched yet? Now, VSR, does it attach at the blue point or the pink point? That's your question. Which point does it attach to?
The purple.
It attaches to the purple one because of the addition law. The two that are added together join end to end every time. Okay? And now I simply get this line here and I join it across. Once again, that triangle in question might be completely out of shape, but once I do the actual maths on it, it'll become more clear what shape it should have been. Okay, so there we go. Right, something like that. Now, let's put in some numbers. Alright, let's begin. Common starting point at the black dot. This is VS. Oh, sorry. VS is here. And then VSR, lads. What? This one's VR. And this one here? VSR. Okay. Let's fill in some numbers. VSR? 2/3. VR? Okay. And we can just rub them out as I go along, just to make things a bit easier. Okay, and the angle, I'm looking for an angle. What angle do I have? 53 points. Yeah, now that's not going to help, but what will help is this green angle here. What is that green angle there? 126.87. Okay, now what can I do? I can use a, what's the goal of the question? How long will it take the swimmer to swim back downstream, straight line? You can go straight into the T method if you want. Do you know the way you're looking for the? Do you know the way you're looking for the time taken? Okay. If I do it this way, I'm essentially looking to find out the actual. I'm looking to find out this yellow line here. See that yellow line there? That yellow line is how fast I travel along this route, the 80 meters. So I can do 80 meters. I can simply do 80 meters divided by that velocity, v. Okay, that'll do the trick. Okay, some of you could end up adding in t's, and then you can turn that into 80 if you want. Your call. Okay. So either way, I'm just going to go with the other method. Alright, so here's what we're going to do. We're going to do, I have to get this angle first. We'll call it angle x, okay? So I will do sine x over 0.5 equals sine 126.87 over 2/3. I will then get sine x equals 0.6. When I bring up the 0.5 and multiply it in, I'll get sine x equals 0.6, and then I'll get x equals 36.87 degrees. You all cool with that? Now, if x equals 36.87, what does that mean for the other angle over the other side? It's going to be 180, take away 36.87, take away 126.87, and we should get 16.26. Now I have access to finishing this off. It's going to be phi over sine 16.26 equals what's this? 2/3 over sine 126.87. Cross multiply up the 16.26. All done. And then what we find out, for some reason I used the cosine rule, I have no idea why. I'll just put this in my calculator, 2 over 3, just to make sure I'm definitely right. I got 0.23 for V, and then that 0.23, it's going to be 80 divided by 0.23, and 80 divided by 0.23 is 300 and what's it? Did anybody get 347.82 or 83, and then change that into what's it? Press the button here. So what's it? 5 minutes and 47 seconds, is it? Alright, you guys. Out of interest, just look at your papers now, lads. In the marking scheme. So the reason why I paused there is, see the way I rounded off to 2 decimal places all the way through. See the way I did that? Sometimes that can create inaccuracies that you're better off to go to 3 decimal places. So they gave full marks basically for 5.7 minutes. So if you had 5.7 minutes, you're in business. You didn't have to do minutes and seconds. So there's a bit of leeway on how many seconds you have. So you could be there's a bit of leeway, like plus or minus 5 seconds in either direction because of the rounding. Okay, so just be aware of that. Generally speaking, you want to round it off a bit higher. So myself and the marking scheme are just slightly small difference, but it's due to the rounding, that's all. Okay.